tam mal something
Spustil som si ale aj tak mám live stream. Máme ešte nesi v reproduktora.
Čo mám robiť? Však sme zapnutí. Haló?
Ani ja mám zase...
Dobre, čaute. Haló? Počujeme sa. Ktorý máme tu z meetupov? IoT Bratislava Meetup, kto došli? Okrem tých, čo poznáme. Nový. Ktorých máme nových ešte? Perfektne. Dobre. Len krátke organizačné a potom switchneme do angličtiny. Takže vás pekne vítam na neviem už ani koľkatom? 34. Koľkatom? 34. meetupe. Dneska bude meetup je organizovaný tak, že máme príspevok od IBM-ky, vrátane zasponzorovania občerstvenia v zmysle pivo a nealko tam a keď sa odprezentuje, potom bude pizza. Dobre? Takže to je k tomu. Čo sa týka témy, nechám Williama predstaviť, čo nám dneska odprezentuje. Dobre? Bude iba jedna téma dneska, lebo potom by sme boli zase do nekonečné, keď to býva a potom máme málo času na diskusiu. Dobre?
Hi, welcome everyone. Can you hear me? So once again, we're gonna be running the session in English. So how many of you are for IoT Meetup here tonight? Okay, yeah, cool. So thanks so much for coming here and finding your time. So we have a great privilege to have Brian Innes. Big applause to Brian. Okay, came straight away from England to talk about what's on IoT, and he's gonna showcase a particular workshop for you, like about the Internet of Things. I think it's really good success that we could make this happen. Thanks, Jan. Thanks, Marek. Thanks for the organization of Cafe Nervosa. And some quick rules, like there is a refreshment for you ready there. You can pick up anytime, and we're gonna have food at the end of the session. So pizza for you. Okay. So thanks so much. I hope you enjoy the session as much as I will. So I'll speak to you later. Thank you. Thank you.
Okay. Thank you. Sorry, it's my fault that we're in English, because you wouldn't like it if I tried to speak Slovak. So, what we're going to talk about today is what it takes to create an IoT application. When I look at most of the demos and examples that I find on the internet, they're all unsecured. We've all heard of things like traffic sensors being used to launch denial of service attacks, and a lot of sensors out there are not secured at all. Live applications where the sensors are being hacked and used for other activity. So when I ask developers about creating solutions, one of the big problems they always tell me about is they can't find good examples of how to create a secured IoT solution. And that's really what caused us to put this workshop together. It's on GitHub, so it's on my account, and it's just an ESP8266 workshop. I was challenged to make a workshop that was really, really inexpensive. My previous workshop, we used Raspberry Pis with Sense hats, and that comes about 70 to 80 euro hardware cost. And everybody used to say that's too much. So the Coursera course I do, that uses a Raspberry Pi, and everybody tells me too expensive. So what we started using were these little things. Has anyone used this, the ESP8266? Yeah, great. They are a great little device. We look today, you can get one for under €3. It's got 4 meg of flash memory, about 32K of program storage, and it's got built-in Wi-Fi. So it's, sorry?
It's all 1 hour.
Yeah.
ESP 30.
Yeah, but that's €6. This is €3. So this is a great little device to get started. And that's what we built the workshop around. So everything that I'm going to talk about here, you can get for under €10. You might have to wait a little while it ships its way from China. If you pay double, you can get local shipping, but €10, you can get it shipped from China, and you can get going. So what we do is we attach a little sensor to it. It's a DHT, this one's an 11, which is a temperature and humidity sensor. And we attach an RGB chainable LED, so a little programmable LED. And those parts together with connecting cables come about €10. But what we do is we show you then how to get a secure SSL TLS connection with server-side and client-side certificates. So we get secured, trusted connection between the device and the cloud. And then we show you how to actually do a server-side application, just to put a dashboard up there, store data into a NoSQL database, and then part 4 is we take it into Jupyter Notebooks, show you how to link the data to Jupyter Notebooks so you can do data analytics. But what we're really going to focus on is the parts 1 and 2. How many of you are familiar with Arduino? I've done an Arduino. So the great thing about the ESP8266, it has a plugin for Arduino. So if you've used an Arduino and all of the libraries you can get with Arduino, you can apply all of those to the ESP8266. So it's really easy. The resolution on this projector is quite interesting. So it's really easy to start creating your application. And in the Git repo, there's a sample application. So what the workshop does, it takes you through how to use the various libraries. So we use the DHT library to read the sensor. We use the Adafruit. Neop can take some of that 4 meg flash and create a file system. And when I do that, I can then upload the certificates and hold the certificates on there. So I don't need to encode the certificates into the application. I can just create them, and as you can see here, just give them a name, and I can now access them off the file system. The tooling allows me to upload that file system. So I just create a directory in the Arduino program, and then I can upload those certificates onto the device and flash it into memory. So what this gives me is an application that is quite happily reading that little sensor. So you can see there 24 degrees Celsius, humidity 33%. And what we're doing is we're sending that to the cloud. But what we're doing in the connection is creating an SSL application. So if I ask who knows MQTT? Okay, there's a few hands gone up. So when you talk about IoT, one of the de facto protocols used is called MQTT. It's Message Queue Telemetry Transport. It was initially created back in the 90s to monitor oil pipelines. So that's when they used satellite communication. And back in those days, it was extremely expensive. You paid by the bit. So MQTT was actually developed to be a very, very efficient protocol with very low overheads. And that's what's really got it going with IoT. So if you go to Amazon, if you go to Azure, IBM, Google Clouds, their IoT connectivity is based around MQTT as one of the standard connections. And the way it works, it's extremely simple. It uses pub/sub, publish, subscribe messaging. So the sender, the producer of the data, it doesn't know who wants the data. If you think of something like a Twitter account, you just tweet and you have no idea who's interested in your tweets. If you're interested, you subscribe. MQTT is exactly that. The producer of the data, which in this case is my ESP device, that's going to send data against a topic. Doesn't care who wants that topic, it just sends the data to the topic. Anybody that wants that data will subscribe to that topic to get the data. And that's how it works. Very, very simple. But the protocol itself does not have any security built in. What we do is we use the standard SSL technology that you're all familiar with your web browsers, and we use that connection technology to add a secure wrapper around the MQTT protocol. And what we do is we use SSL with certificates. Anybody here familiar with the OpenSSL toolkit? Have created their own certificates? Yep, maybe a couple. So the great news is there is open source technology. It's called the OpenSSL toolkit. It's installed by default on Macs and most Linux distributions, and you can easily add it to Windows. And what it does is allows you to generate your own certificates. If you're a web browser, you need to use the well-known root certificate authorities because you've got no idea who your browser is going to talk to. So if you're running a web server, you typically have to pay somebody for a web certificate for your server. With IoT, you're often talking about closed systems. The device is going to speak to your server and nobody else. So you know who the IoT device is going to talk to. So a lot of IoT solutions can use self-provisioned certificates. So the OpenSSL toolkit is a toolkit that allows you to create all the certificates you need to secure that SSL connection. So before we actually get into the OpenSSL toolkit, there's a couple of things we want to talk about with SSL. First of all, it uses two different types of encryption. I normally draw a picture about this, but I've got no whiteboard, so I'm just going to have to explain it, and hopefully you'll understand it. The first one is called asymmetric or public key cryptography. And that's where you have two keys. One is used to encrypt the data, and a second key is used to decrypt the data. And they work both ways around. So I encrypt with one, decrypt with the other. I can then encrypt with that one and decrypt with the first one. I can't encrypt a message with the same key I can't decrypt it with the same key I encrypted it with. They come as a pair. So if I keep one of those keys to only myself as a private key and give you all access to the other key, whenever you're sending messages, you know that it's only me that you're talking to. Because if you encrypt it with the public key, only I can decrypt it with the private key. And if I encrypt it with the private key, then you know it had to come from me because I'm the only one that's got that key. So that's a principle with asymmetric cryptography. And that's what certificates are based on. They're based on one person signing that certificate, encrypting a signature with that private key, and then the public key is provided. So you know the person that signed that certificate, their identity, because only they hold the private key. The problem with asymmetric cryptography is it's very, very computationally expensive. So you need a lot of maths and a lot of computing power to be able to do those encryption and decryption algorithms. The other sort of cryptography is symmetric or private key. And that's where you have a single key that can both encrypt and decrypt a message. And that is relatively cheap, computationally wise, versus the asymmetric. So SSL uses both types of cryptography when it's creating a secure session. And it also uses these things called certificates. So a certificate is a collection of information, which normally includes who the certificate represents, maybe the company name. If it's a server certificate, it will have the domain specific name of that server. It'll usually have a start date and an expiry date. And then what happens is you use a special function called a hashing function to look at all the information in the certificate to generate a hash, a unique number which represents all the information in the certificate. And then I encrypt that with my private key, and that becomes a signature to the certificate. Now, if anybody changes any information in the certificate, the hash key will no longer match. The hash function will no longer match. So if I receive a certificate, I should be able to use the hash function to generate that key and compare it with the decrypted signature. And if they match, I know the certificate has not been modified. But I also know who signed it because I have the public key and they had to have signed it with a private key. So with certificates, I know who signed it. It contains the host name of the server. So my little device can now look up and say, yes, the IP address I'm speaking to resolves to this DNS name, and that's what's in the certificate, which is now signed. So I now have a trust that the person I'm speaking to is who I think it is. So with the certificate, the digital signatures, I can then establish that there's no man-in-the-middle attack. I'm speaking to the server that I expect to be speaking to, because nobody else would have the private key. And then the other thing that we need to look at is chains of certificates. And the way that the browser works is we have well-known root certificate authorities. So if you look in your browser, oh, this is too small. So if I go to preferences, okay, and security, and certificates and authorities, these are all the certificates, authorities that exist in Firefox. So you see there's loads of them. And then what happens is these companies agree to do certain checks before they issue a certificate. So if I went and applied to one of these companies and said, I'm Acme Inc., they'll say, prove it, before they're going to give me a certificate. And they have to do a certain amount of checks before they can issue a certificate to make sure the person receiving the certificate is able to act on behalf of that company. So what then happens is they will sign a certificate for me, Acme Inc., and because your browser trusts the person that signed my certificate, when I present that to your browser, you can verify the signature from them, and then you know that I'm Acme Inc. So you have the root certificate that signs other certificates. And these chains can be multiple certificates long. And the idea is you know the root certificate, you trust the root certificate. So by trusting that, you trust the next certificate, verify this signature. That can then be used to sign another certificate. You trust that until you get to the server certificate. So we can apply the same techniques to our IoT devices. And what I've done in the course is given you the instructions. So we're going to create our own root certificate authority. So we're going to create a self-signed certificate. And these are the actual commands you need. So if you've got the OpenSSL tool installed, these are the commands that will actually generate you your root certificate. And you're going to get your private and your public key. You give the public key into the web server, or the MQTT server in this case, and you're also going to put it on the device. So any certificate signed by that root certificate will be known by the cloud platform and also by this device. And then once we've got that, we need to generate a server certificate. Now this time we're going to use that root certificate to sign the server certificate. And then that needs to be installed onto the cloud platform. And then that means if the server presents that certificate to my device when I connect, I can use a root certificate, which I've stored in there, to verify that certificate. So I now know that I'm speaking to the right server. And by having that certificate, it means we can generate an encrypted messaging mechanism between the client and the server. So when you start off with OpenSSL, the client will contact the server, and it will usually tell it what protocols it understands. So with SSL, there are a lot of different algorithms that you can use for the asymmetric encryption, for the hash function to generate the signature, and then for the symmetric cryptography. So the client tells the server, I understand these algorithms. The server will then choose one of the sets of algorithms that it can do and say, we're going to use this set of algorithms for the asymmetric, for the hash, and for the symmetric encryption. And then the handshake continues with the server sending its certificate down. The client is going to look at that certificate, check that the signature is valid. It's going to look at the DNS embedded within the certificate and make sure that's actually who it's talking to. So if that DNS isn't the same IP address that it's talking to, it'll actually say that it's not a valid certificate. It'll also look for the start time and the finish time of the certificate. And if all of that matches, the client says, I trust that certificate, it's valid. Optionally, the client will then send its certificate back to the server, and the server will do the same thing. Can I check the signature? Is it a valid certificate? The client certificate doesn't have a DNS name because it could not have a static IP address. A lot of IoT devices don't have a static IP address, but it will have an identity embedded within it. So different certificates have different information embedded in them. But it's the same principle. I now know who the client is, who I'm talking to. And then once they've agreed and checked each other's certificates, the client generates this random bit of information, sends it to the server, which is encrypted with the server's public key, so anybody snooping in can't understand that. The server then takes that same random thing, and then both the client and server use a standard function to generate a private or a symmetric key. The client sends a message to the server, encrypted with that key. If the server can decrypt it, it then sends a message back, again encrypted with that key. And from then on, they both agree to use symmetric encryption using that generated key. And that's how SSL works, whether it's on your browser or whether it's the IoT device. So they start off with this expensive asymmetric encryption, and then very quickly they jump down to symmetric encryption, which is a lot less computationally expensive. And the reason I tell you that is because we run a workshop in IBM today, and the guys that were there will say, this stuff really sort of messes with your brain when it goes wrong. Just trying to set up all the different parts, getting all the parameters right, it can be quite a challenge. So the other great thing with the ESP is you can turn on debugging. So you can debug the SSL and TLS connection, and you get to see all of these pieces played out. You get to see all the certificates that were sent from each party, and you can go through and verify what's working and what's not working, and where you've gone wrong, which is quite indispensable when you first start out, and it just says, sorry, can't connect. This is what helps you work out why it can't connect. So now that we've actually got our certificates, we've used the OpenSSL toolkit to generate our root certificates, our server certificates, and our client certificates. We can upload them onto the device. And on the cloud, now I'm using the IBM cloud here, but if you've got other MQTT brokers, the same principles apply. So within the security section of the platform, and this is where the screen size gets a little challenging, I get the option to add my root certificate, which I've added here. I also get the option of selecting the server certificate. So this is what the server is now going to send back to my device when it connects. And then I get the option of telling my MQTT server what are the connection security I want. So by default, it just sets TLS with a token or a password. But I've got mine saying that I want an SSL connection, you've got to have a client certificate, and you've got to have a user password or a device password. So that's as secure as you can get. We've got an encrypted SSL connection. The client has to deliver a valid certificate, which is signed by our root certificate authority. And I need a device token, which is agreed between the platform and the device. So then if I just go back and reset this device, you can hopefully see the trace output there. So this is it connecting to the Wi-Fi. It loads the certificates up. Remember I said that we had expiry time, a start date and expiry date in the certificate. So to get that working, I have to talk to the local network time protocol provider. So I use NTP to get the current date and time. And then we get a message to say that all the certificates have matched, and we've now got an SSL connection, which then allows us to complete the MQTT connection. And once I've got that, I can send data, and I'm just sending as JSON the temperature and the humidity reported from the device. So that's the first part. So that's us now created our program on here. We're talking to the hardware. We've created the SSL encrypted connection. So, does anyone recognize this? Okay. So this is a technology called Node-RED, and it's what we use all the time when doing proof of technology, proof of concepts. When I do hackathons and I introduce Node-RED, I issue challenge to any developer in the room. If they can write a server-side application in code of their choice quicker than I can using Node-RED, I'll buy their beers. If I can do it quicker in Node-RED, they buy the beers. Nobody's taken me up on that challenge yet. Because, quite honestly, this application, which generates this dashboard in real time, it takes about 25 seconds to write the application in Node-RED. It really is very, very quick to do. So I've got the data coming in here from my MQTT server. So this comes in as JSON. I then run a switch. And what this is doing is it's trying to work out what the temperature is. And depending on the temperature, it sends the output out of these different connection points. So if it's below 0, it comes out of this one. If it's between 0 and 9, it comes out of this one. If it's 10 and 24, if it's 25 to 30, and it's above 30. And then what each of these does, they just create a JSON document at the bottom here. And you can see they've got a red, green, blue value. And that is just the value that I want this light to show. Now, this is very, very simple analytics. In reality, I could pull in the weather forecast. I could pull in some other statistics to predict what the temperature may be in the next hour. So if I was doing some monitoring of something, then I wanted to know if it was a greenhouse, am I likely to get frost tonight? Or is the temperature or the humidity going to exceed certain limits? Do I need to water the greenhouse? Do I need to open a window? Do I need to close a window? So I could be doing any analytics like that, but for this example, I just use that simple switch. And then what happens, this gets sent back through the IoT platform as a command. And that is picked up here, and you can see the values coming here. So every time I send it a temperature, I get the value that the RGB LED should be. And I can use my very scientific breath to actually alter the humidity and the temperature. It only fought every 10 seconds. So there we go. I've got up to 31, and as expected, the light's gone red. You can also see the RGB value has gone to 255 on red, nothing on green and blue. I can look at the graph. And you can see the spike there. You can also see we got alerts coming out. So we can actually have browser-based alerting coming out. So you can see the spike, and if we just leave it over time, that's now going to revert back to the normal temperature and humidity. So again, about 30, 45 seconds of programming gets me that dashboard and gets me that server-side logic. What I can also do is I can, with the same Node-RED, I can get the data stored in a database, either a SQL or a NoSQL database. And it's that easy to actually get that working as well. And then this is a historical chart where it actually pulls the data out of the database, and then it will actually graph it. So you can see, very, very simple to actually go in and get that data working. And in the workshop, in part 3, this is what we do. We actually show you how to set up Node-RED, and then how to get the data. So it takes you through exactly how to create those flows that I've just shown you, and everything you need to do. If you haven't used Node-RED, it's worth having a look at. It's available, it's open source technology. It was created in IBM by one of my colleagues, and we've given it to the JS Foundation. It's part of the Linux Foundation. So it's open source technology. It's freely available. It runs on things like Raspberry Pi, BeagleBones, your laptop. It runs on the cloud, and it's very, very easy to get things going. So then the last thing I want to show you is what happens if you haven't got any hardware. So we just talked about how to get it going. And before I talk about that, I will just show you here. If you want to play with this workshop, what I've done is I've given you all the parts that you need. And I've given you search terms. So if you go to eBay or Amazon and you put these search terms in, this will typically get you the hardware. This will show you what you need to buy. Again, that's about €3. You've got the LEDs. These usually come in packs of 5s. So you've got a couple, €2-3 for a pack of 5. You've got a humidity sensor. Comes in 2 varieties. You've got the one I've been showing you, which is the blue one, and that is plus or minus 2 degrees Celsius. And it's about 3 to 5% accurate on humidity. You've also got a slightly more expensive, it's about double the price. So this is about €2, €1.50, €2. And this is going to give you plus or minus 0.5, sorry, plus or minus 0.5 degrees. So this is going to be within half a degree Celsius in accuracy. So a lot more accurate, but double the price. And the library will work with both of them. And then you just need a few connectors and a USB cable to get it. In the setup, I also take you through everything you need, whether you're on Mac, Windows, or Linux. I take you through setting up the driver for the board, setting up the Arduino IDE if you haven't got it, and then you've got the two plugins. You've got the plugin to actually be able to compile the application, and then the tool to be able to upload the Flash file system. And then when working with SSL, it's usually installed with Linux and Mac. Windows can be a challenge. You've got two routes. You can either install a pre-built binary, and they're available. I've got a link to the site that actually makes those available for free. Or you can install the Windows subsystem for Linux. And what that does is it puts a Linux distribution within Windows, which means you get access to all the nice command line utilities that you're familiar with if you're on Linux or Mac. So you can either do either of those options to get access to the SSL toolkit. And then within the workshop, we use the IBM Cloud account. We're from IBM, so why wouldn't we? You can get it for free, costs you nothing, don't need to put a credit card in. So you can just sign up and you get unlimited use in terms of duration, but you get a cap on the amount of resource you can use, which I think is fair enough. Oh, and if you have an IBM account, we've got promo codes which gives you extended resources for 6 months. Yep, wow, okay. Okay, and then the last part of the workshop, which I'm not going to show you because it gets really, really detailed, is if you're a data scientist, you probably use Jupyter notebooks. And then you're going to use things like TensorFlow or Spark, Apache Spark, to actually do deep analysis on. And the end of the workshop, it actually goes through that. We use the environment on the IBM Cloud. It's called Watson Studio, and you can deploy it. And what it does is it shows you a little trick to get the data from your Cloud and NoSQL database into the Jupyter Notebook. One of the limitations you have on your resources is the data rate. I can't do more than 5 transactions a second on a database. Now, if I've got 300, 400 sensor readings, I can't just do the Jupyter. And it just does some very, very simple analytics. So if we just look at it, it's really just looking at the min, max, standard deviation of the temperature data that you've actually got in your database. But all the instructions are there to actually get that working from your live data. So that is all really I wanted to talk to you today. I've got all the kits here. You can come play with it. You can come and look at the code. If you go into Git, look under my name, and then look at the workshop, you've got all of the instructions step by step, so you can actually recreate this. Actually go create this. The most useful part when I speak to other developers is this part 2. Because just creating the self-sensitive, and that's a base 64 encoded text format, and then you've got a binary format, which has usually got a DER extension. And we show you the command here to actually convert from one to the other. So if you follow these instructions, you get both the text and the binary. These devices typically use the binary formats, so you can need both. So any questions?
I was just going to ask you about, you're talking about some services which are interconnected with Node-RED, maybe, that I already have some nodes in Node-RED up and like at my disposal for the IBM Cloud. And actually, me and my colleagues, about 2 years ago, we saw a very nice presentation about the whole building management system done in Node-RED and running on Bluemix API. I didn't know back then that Node-RED was developed by IBM. How long ago is it? It was sold out from IBM, or is it still developed by IBM?
Okay, so I should know this because we've just had a big anniversary and we had the timeline on the wall. I think Node-RED was initially invented in 2014, so it's only 3-4 years old. We gave it to JS Foundation 2 years ago. It's always been developed on OpenGit, so it's always been under an open source license since very early on. But we actually formalized it and handed it over to JS Foundation 2 years ago. Developers from IBM are still the principal developers, but we've got developers from a lot of other companies, such as Hitachi. Node-RED is part of product releases from a number of companies. So if you go and get the Intel IoT Gateway, Node-RED is part of the user interface. And there are quite a few other companies that have embedded Node-RED. But IBM is still one of the principal contributors, but not the only one now.
So only just a second, small question. Is it possible to find some nodes relating Watson cognitive services directly in Node-RED? Because the presentations most focus on some of the cognitive services on Bluemix API, and it was astonishing what they could do with those. So I was just wondering, I was actually going to develop my own little application next month, and I was just wondering about developing it on Node-RED. And if there is anything I could use from Bluemix cognitive services, I would definitely try.
Yeah, most of the Watson services have a Node-RED node.
Okay.
So that's it there. So if you don't know, flows on the node-red.org website, this is a database of all the nodes available. So you can look here and get access to all of the nodes, how to install them, and it shows you the nodes available. So we've got sort of natural language, text-to-speech, speech-to-text, visual recognition, translator, discovery, and then the chatbot, digital assistant. So a lot of the nodes are there. The other thing is, because it's open source, it's really easy to create your own nodes. So if there's not one there that you need, it is very easy to go and add a node. A little plug, myself and the creator of Node-RED, we created a Coursera course where we go through using Node-RED and also creating nodes. So that course also covers creating nodes. So if you just look for me under Coursera, you'll actually get the 2 courses that I've contributed on. Anybody else? Okay, so, yep. What happens with the food now?
Yeah, it'll be good.
Do people need to order or?
I think I will ask you.
Hi, I wanted to ask you about certificate management.
Yeah.
So when you run out of validity of client certificates and the server certificates, how do you manage to renew them? Or there is some function to send certificates over the air into the ESP or something like that?
Also, are they valid throughout the time, like for 2 years or so?
Okay, so certificate management is another quite big topic, but if you're managing your own certificates, you can actually renew a certificate. So you can actually take a request and then renew it. In terms of getting a certificate to the device, these devices have over-the-air updates built in, so you can actually do over-the-air updates. It's also possible to use things like MQTT to distribute the next certificate and put a go live date on them. It's all going to be custom code because these devices, there's no operating system on there, so you have to use your own code to actually manage the certificate on device. But it is possible to put a sort of the next certificate on here and then switch it live at a certain point. So you can do all that functionality on the device. There is some device management capability within the platform, and there are separate products which do device management, which include things like firmware updates and certificate updates and configuration updates, which you can push over the air. So there are ways of doing it. With small devices like this, where you don't have an OS, you typically have to use a library or write the code yourself. But yeah. And that is one thing that we don't actually cover in the course. Where possible, you want to try and remove all configuration, certificates configuration, out of the source code. So you have one binary, you have a configuration, and then a set of certificates, and they can be managed and pushed using a device management framework. So yeah.
We got 20 minutes before the pizza comes, so feel free to share more.
Okay, yeah, we got 20 minutes before the pizza arrives, apparently. So anything else? Any other questions? Okay, so we can just sort of chat. Come chat to me, come talk amongst yourselves, get some drink, and then the pizza will be here in 20 minutes.
You can exchange business cards, chit chat, whatever.
Yeah, get in touch with Brian.
Networking, and you can directly ask Brian, our expert, and pizza. Question: would you like to order your own pizza, or is it fine to bring just some pizzas out and you're gonna eat whatever? It's up to you guys.
Are you hungry?
Yes.
I know somebody already eaten. It's already covered. No, that's covered. It's already covered. So, because I ordered random pizza, margarita, vegetarian, salami. But if you want specific, just let me know. Now you okay? Okay, so it's going to be 4 random pizzas and chit chat talk. The space is ours.
I will just.
Yeah.
So I will like wrap it up, and thank you very much, Brian. This was very interesting. And I would like to invite you all to the next meetup, which we don't yet know when we will be, but it will be definitely interesting as well. And this one was actually quite special. So, thank you. Bye.
Thank you. Thank you, guys.